In today's lesson, we'll be learning about the method of substitution. In our first example, we want to solve by substitution. Solving a linear system means finding the point of intersection of two lines. Instead of doing this graphically, you can do this algebraically. Our first line is in slope-intercept form, y equals negative x plus 8. Our second line is in standard form, x minus y equals 4. Take a close look at these two lines. You want one of these lines to have a variable isolated. As you can see here, the y has been isolated already. If no variable has been isolated, you need to isolate for that variable. In our second equation, you can see that y is over here. What we're going to do is we're going to replace that variable of y with this expression. We're going to substitute it in. Before I begin, I'm going to call our red line equation 1, and I'm going to call my blue line equation 2. As mentioned beforehand, I'm going to sub equation 1 into equation 2. Start with our second equation, which is the blue line. X minus y equals 4. As I said before, we are going to replace y with the expression negative x plus 8. I'm going to put this in brackets and in red. Before I go on, I'm going to need to simplify both sides of the equation. If you have a number in front of a pair of brackets, you need to use the distributive property, which means I'm going to distribute a negative 1 to everything inside the brackets using multiplication. So negative 1 times negative x is positive x, and negative 1 times positive 8 is negative 8. Next, I'm going to collect like terms. X and x are like terms. Therefore, x plus x is 2x. The negative 8 stays the same, and the 4 stays the same. Remember, you want to isolate x. However, x is stuck with a multiply by 2 and a subtract 8. We want to get rid of the subtract 8 first, so I'm going to add 8 to both sides. Negative 8 plus 8 cancels out, which leaves me with just 2x, and 4 plus 8 is 12. I need to get rid of this multiply by 2, so I'm going to divide both sides by 2. These 2's cancel out, which leaves me with just x, and 12 divided by 2 is 6. Therefore, I just figured out the x-coordinate of the point of intersection, and that is x is equal to 6. Now that I have the x-coordinate of my point of intersection, I need to find the y-coordinate of my point of intersection. And I can do that by substituting in my value of x into either equation 1 or equation 2. As you can see, it is probably easier to use equation 1. Therefore, I'm going to say sub x is equal to 6 into equation 1. We start with y equals negative x plus 8. I'm going to change the x into a 6 in brackets, and the plus 8 stays the same. Therefore, negative 6 plus 8 is positive 2. So the y-coordinate of the point of intersection is 2. Let's write a concluding statement. Therefore, the solution, which is the same thing as a point of intersection, is 6, 2. Now that we have our solution or point of intersection, we need to make sure that it lies on both lines. So both line 1 as well as line 2. We are going to do a left side equals right side check. I'm going to say sub 6, 2 into equation 1. So I'm going to start with y is equal to negative x plus 8. I'm going to replace the y with a 2. And I'm going to replace the x with a 6. Simplify both sides of the equation. The 2 stays the same, and negative 6 plus 8 is equal to 2. So left side is equal to right side. Therefore, this point lies on line number 1, the red line. I'm going to do the exact same thing for the second line. I'm going to say sub 6, 2 into 2. Let's start with our equation, which is x minus y equals 4. I'm going to replace the x with a 6 in brackets, and I'm going to replace the y with a 2 in brackets. Simplify this, so 6 minus 2 is 4, and 4 is equal to 4. Therefore, the left side is equal to the right side, which means this point lies on this line, the blue line, or line number 2. Let's write a concluding statement. Since left side is equal to right side for equation 1 and equation 2, therefore, the solution or point of intersection is indeed 6, 2.